Every single day, probably dozens of times a day, there's this silent security guard checking your ID. It happens when you unlock your phone, when you log into your email, when you open a work file. This whole invisible dance of authentication and authorization, well, it basically runs our entire digital lives. So let's break it all down. Seriously, think about it for a second. When you put your thumb on that sensor or you let it scan your face, what's really going on under the hood? You're kicking off this incredibly sophisticated digital handshake that's all about proving you are who you say you are. And this isn't just about your phone. This is the absolute bedrock of all digital trust. All right, so here's our roadmap for this. First up, we're going to tackle the digital ID check, just getting past the front door. Then we'll decode the secret handshakes, the protocols that make sure that check is actually secure. From there, we'll grab the all-access pass with single sign-on. And once we're in, we'll figure out the rules of the house, what we're allowed to do. And finally, we'll check out the smart next-gen security that's always watching our backs. Okay, first things first. Before you can get into any system, do anything at all, you've got to pass that initial security screening. This is that make or break moment where you show your digital credentials and the system checks to see if your name is on the list. And that brings us to the core idea here, authentication. It's really just a fancy word for the process of proving your identity. The whole point is to keep the wrong people out and let the right people in. Think of it like the digital bouncer for every single app, website, and network you use. So how does a system actually know it's you? Well, it pretty much boils down to three fundamental ways to prove it. It can ask for something only you know, like a password or a PIN. It can check for something only you have, like your phone or a physical key. Or it can verify something that you uniquely are, using biometrics like your fingerprint or your face. Now here's the real pro tip. The best security, what we call multi-factor authentication, never ever relies on just one of these. It always mixes and matches at least two. Okay, so you've got your password ready to go. But how does that password get from your keyboard all the way to the server without some eavesdropper grabbing it in transit? Well, that's where protocols come in. You can think of them as the secure, secret languages that computers use. It's like a digital handshake to confirm who you are without shouting your secrets across the room. Now, the oldest and, frankly, the most basic version of this handshake is called PAP, or the Password Authentication Protocol. And its method is, well, it's shockingly simple. It just takes your username and password and sends them over the network as plain, readable text. And yeah, that simplicity is its absolute fatal flaw. Sending your password in plain text is basically the digital equivalent of writing it on a postcard and dropping it in the mail. Anybody who happens to be listening in on that network can just read it. It is a huge, gaping security hole, which is exactly why the modern internet just couldn't possibly run on something so fragile. So, to fix this massive problem, we came up with a much, much smarter protocol, CHAP, the Challenge Handshake Authentication Protocol. And the genius of CHAP is that it can prove your password is correct without ever actually sending the password itself. Okay, here's the clever part. Instead of you sending over your password, the server sends you a random puzzle, what it calls a challenge. Your computer then uses your password, which is the shared secret, as a key to solve that puzzle. It calculates the answer and sends that response back. Meanwhile, the server, which also knows the secret key, does the exact same math on its end. If the two answers match, bingo, it knows you have the right key, the right password, and you never had to send it over the network. Pretty smart, right? I mean, let's be honest, we have so many accounts these days. Email, cloud storage, team chats, you name it. And logging into every single one of them is just a pain. That's exactly why we invented the digital version of a master key, or an all-access pass. It's called Single Sign-On, or SSO, and it's a brilliant system that lets you log in just one time with one set of credentials and then get access to a whole bunch of different apps. It's a total game changer for convenience, and it can actually be a big boost for security too. A lot of us are already using this every day at work, even if we don't think about it. You sign in once in the morning with your company login, and that one single action gets you into your email, your cloud apps like Salesforce, and all those internal company websites, without ever bugging you for another password all day. Now, behind the scenes, there are a few key technologies making all this magic happen. You've got SAML, which is kind of the workhorse for all those big corporate apps. Then there's OAuth. That's the one that lets you give an app limited permissions, like letting it see your contacts without handing over your entire password. And finally, there's OpenID, which works hand in hand with OAuth. You see this all the time with those super convenient sign in with Google buttons. And here's the perfect real-world example of OAuth's power. Imagine a new fitness app asks for access to your phone's health data. You're not giving that app your main phone password. No way. Instead, what you're really doing is giving it a temporary, limited access key, a token, that only lets it see the specific health data it needs and nothing else. Your main login, your real password, stays totally safe and secure. All right, so you're authenticated. You're in the building. The bouncer let you past the velvet rope. But that doesn't mean you can just wander into the VIP lounge. Now we have to shift gears from authentication, who you are, to authorization, the rules that say what you're actually allowed to see and do now that you're inside. So who actually sets these rules? Well, there are a few different ways to do it. The simplest is called DAC, or Discretionary Access Control. That's where the owner of a file decides who gets to see it, just like when you share a personal Google Doc. On the complete other end of the spectrum is MAC, or Mandatory Access Control, which is used in places like the military, where the system itself assigns strict security labels like top secret. But most companies use something in the middle called RBAC, or Role-Based Access Control, where your permissions are based on your job title. And finally, for really complex cloud systems, you have ABAC, which uses all sorts of dynamic policies and attributes to make decisions. But just having a static set of rules isn't always going to cut it. The threats we face today are constantly changing, so our security has to be just as dynamic. And that brings us to our final layer, the intelligent, next-generation security that adapts in real time. This is the big idea behind something called conditional access. Instead of just checking if a password is correct, the system looks at the entire context of your login attempt. It's a much smarter, more adaptive way to do security that asks a lot more than just, did they type the right password? So what kinds of things is it checking? Well, it's looking at all sorts of signals. What's your location? Are you suddenly trying to log in from a new country? What about your device? Is it a secure company laptop or some random unknown phone? It even looks at the real-time risk of the login itself. And if anything seems just a little bit off, it can block you or demand more proof, even if you got the password right. So when you put it all together, from that first ID check at the door to the secret handshake of a protocol, all the way down to the specific rules of what you can do once you're inside, all of these layers, authentication, authorization, and conditional access, are constantly working together. They create this deep, powerful defense to protect every single piece of your digital identity. So, we've seen how all these incredibly complex layers work together to protect us, from our simple password all the way to these automated rules about our location and device. And they offer us amazing convenience and security. But they also make these autonomous decisions about our digital lives based on data points we never even get to see. And that leads to a pretty interesting question. As these systems get smarter and more complicated, who is ultimately in control of your digital self?